So here we are already in the 11th week of the semester. We're doing inferential statistics, and it's that point in which some of us are considering or worried about the final project. Well, this is why we're looking at this blank page, this daunting, these 4 pinned windows that have combined. I'm hearing a little bit of extra sounds here. That might be my own computer. We see the pinned windows here. This is should be familiar to us, except this time we don't really have anything. You can see a little bit of lightness here. I'm just going to show you what you can do beyond this course, beyond following orders, beyond following what it is that we tell you to do each week for analysis. And that means really pulling and finding your own data. So first things first, if we look at this console, you'll see something right here. I want to annotate. Spotlight. You can see that if there's an analysis, and I pointed this out before, we're doing it somewhere. This is called a relative path file. You can open it here. You can view what's called the current working directory. Sometimes the present working directory, PWD. There's a bunch of other junk here. I've created some subdirectories. I don't really care for that. We actually want to create a new directory. And this is probably the best approach to take your analysis, which is basically, first goal is when you're working on the final project, and the assumption is going to be that whoops, I don't know if you can see that. Oh, I know why. I don't have the mouse trigger. Okay. The assumption here is that you're basically going to, we're going to go and find a data set. We're going to import it into R, and then we're going to munge it or clean it, and then we're going to do something with it. Now, I'm just going to show you the first part of this, which is essentially going out there and importing data from out there into this little box here. The main reason being, there are many different kinds of data sets other than those that we have dealt with in class. So then that's going to be our main goal, really. It might seem a little modest, but let me save the script here to the desktop. I'm just going to save it right to the desktop. And we're going to change our working directory to the desktop. I don't care. So let's do that. And this is just, it'll be called import data. Okay, I have a script called import data. And we're going to import data 4 ways if we have time. I'll give you a preview here. The first way is within R itself. Take advantage of the wealth of built-in data frames. We're going to call these data frames because this is our lingo. A data frame is simply a matrix where the number of rows are equal across columns. So even if there are missing observations, the number of rows are equal. It doesn't matter whether you look at one variable or one column or another, they're equal. Now, if we think about the kind of data frames that we have in class, we have given you sort of the package deal. This is like going out to eat at the finest restaurant where with white tablecloths, because we gave you nice, clean, what are called tidy data sets. Tidy data. What does this mean? Well, it means that every row counts, every cell has a meaning. There's no dirt in the data. There are no meaningless symbols there. And in fact, we even made it easier for you because we had not just tidy data in the sense that missing values were systematically dropped or imputed, but we also had names for the data sets that weren't enormously large or just like a string of numbers. We didn't have too many variables. We didn't have, I don't know. We didn't have data sets that were so large you weren't even sure what to do with it. Or we didn't have data sets that were that can be troublesome in so many ways. It's sort of like the old Tolstoy quote in War and Peace. He said, "All happy families are happy in their own way. All unhappy families are unhappy, each in their own way." It's the same with data. Tidy data are pretty much tidy in their own way. Untidy data, it's going to look messy in many different ways. And that's really probably, truthfully, 90% of the work is really getting your data in order. So we're going to talk about this idea of tidy data in the sense that I'm just going to remind you what the suffix is for the data sets that we have in class. These are called R data files. When we talk about R data files, these are tidy data because R can read them in. R recognizes them as a type of object. That is something within the global environment that isn't that problematic. So I'm saying there's some good news amidst all this, which is the fact that there are lots of data frames. There are these .r data files already built in. You might have to install the package. You might have to find other kinds of packages, but they're going to be there. And in fact, I'm going to show you, if you look at the discussion board, I have a handout there. But I'm actually not going to show you the handout, but we're going to stay within RStudio. And I'll just give you the link here because I want to show you this hist data package. Whoops. But the idea of importing data within R, before we do anything with data, I want us to get used to this idea of getting our working directory in order. These are the preliminaries. So we want to get the working directory. What does this mean? Well, this simply means, if you're having trouble hearing me, I apologize. This is going to get the working directory. It'll tell us where we are. Look at all this stuff. I don't want to be here. In fact, I want to be just right on the desktop, as I said before. So what I'm going to do is I'm going to copy and paste where I want to be. And I'm going to use this other function called set working directory. What this does is that it keeps in a consistent fashion the location of my analysis. In fact, I'm actually going to, I believe this is a function, load data. Let's see if, I think that's a function. I could be wrong. No, it isn't. Okay. Well, I'm just going to do this. We can go to the Files tab. Here we are we can go to the desktop. There's a bunch of junk here, but we want to go in this desktop. We're going to do a new folder, and we're going to call this tidy data. So here we have our home. That's what we're going to have. That's what we call tidy data. Did I type types of data? I hope not. No. I'm going to click on that. If you click on that, that is now our present working location. That's our setting. That's actually our working directory, and you can check that if you just run line 3 here. No, I'm sorry. Just because you set it within this pane doesn't mean that you actually define it that way. I should have thought better. Now we really want to actually set our working directory by defining it by this relative path file, home, desktop, tidy data. Well, we got desktop, and now we're just going to add to this tidy data folder. Remember that R is case sensitive. So in that sense, when it reads any kind of thing in quotes, these are called strings because it's in quotes. It's actually a type of data. This is a function that says to R that whatever string, whatever gobbledygook we put there, which is the location of our analysis, we're going to stay there every time we do the analysis. So in fact, for now, I'm going to eliminate the get working directory function, or rather, why don't we comment it out? Because we just want to set the working directory. We want to be consistent. We want to do this each time. So we set the working directory, and that gets rid of quite a bit of work for us because then we're not loading data sets from different places. Our goal is to put the data sets that we want for our analysis in that tidy data folder. This is as basic as it can get. More complex analyses, more complex projects would include different subfolders or different contingent folders, or raw data, then clean data, and then analyzed data, and then another data with figures. And then you can also use different kinds of scripts here to actually create or interweave your analyses within the presentation. So if you're familiar with any kind of markup files, you can do that. Our Markdown's really cool. You can do a presentation. LaTeX is another kind of manuscript creation language, a scripting language. But there's lots of different kinds. We're keeping it pretty simple. All we're saying is we got a box, we got this place, and it's going to be inviolable. We're going to do our analyses here, no matter what. And I did that partly through GUI, through using these commands here, and also through this set working directory function. Really, that's often might be the best combination. And you will see this when we import the data sets. Look at this. If in doubt, and you have trouble with importing data sets, use this function. Look at this. This is probably the best thing you can do, which is essentially first recognize that you don't have to do everything through the scripting line. But second of all, you should recognize the different kinds of data sets that you are going to encounter. So if you don't know what SPSS is, you don't know what SAS is, you don't know what Stata is, be familiar with those. Now there are two other kinds of functions here. One is getting more attention than lately is this readr function, precisely because it's modular. It works across different kinds of data sets or data frames. And that's because when we read in other kinds of data, as we'll learn, we're going to read mostly what are called tabular data sets, spreadsheets essentially, where cells are delimited or separated by commas, by tabs, by something else. But when we talk about this first step, built-in data frames, we don't have to deal with this. But we still have to deal with, by the way, the fact that if we're going to use R's own data, we want to make sure that we save R's data frames within the same place. This is why I started off the analysis with setting our working directory. I know this is a little dull, but we got to do it. And in fact, it's always nice to see what's in your directory. So you can do this. There's nothing there. You can also get your working directory if you just want to confirm, where you are. And there we are. There's there's my name. There's desktop. This is where my project will live, and this is what I like to see. It's about as simple as you can get. I don't think we need to make it more complex. What else did I want to say here, except that when we do this, this means that we can actually save files here. So even if we're using built-in data sets or data frames, we still want to save or write those data frames to the working directory, present working directory. Because if we're going to reanalyze something, we don't want to just, reinvent the wheel, as it were. We want to actually, find it again or do it again. So this is an important component of that puzzle. So the function, so first what we're going to do is we're going to actually, we're going to read in our data frames, our data. Okay, and then we're going to write our data to our present folder, present working directory. So what that means then is we're going to take something from within the underbelly of wherever our packages are lying, some complex path file, because every package includes certain data sets, or most of them do, as examples, and base R does include data frames. And then we're going to take that, and then we're going to save a copy of that to our present working directory. And that's basically what we're going to do when we talk about this. And then when we write our data frame to our present working directory, then we're going to just do what we want with it. That's kind of how we want to be. We want to be basically how you are at the beginning of every mission, where you have a data frame in the right-hand corner. It has a nice name. You don't have to deal with anything. Your life is simple. But there are some decisions that have to come here. So how do we read in our data? I'm going to say read in built in the data. This is not always used, but this is the function of the de jure. You want to use this one. It's called the data function. And if you recall, my tutorials on help files, put a question mark there. This is what you want to do. This will give you the help file, the standardized help file, which includes the official name. It's essentially the description. It loads specified data sets or the list of available data sets. parentheses, I should say, within R. These aren't just any data sets. These are data sets within R. And there are a bunch of arguments here. You don't really have to know about many of these things except for the fact that sometimes you might have to specify some aspects of these arguments, but typically you will not have to. But if you want to specify it, like say, for a particular package, you might have to, but typically you won't. And the best thing you can do is to look at data sets. To look at whenever you look at help files, I always say look at the bottom, because if they're at the bottom, you can either see one of two things. You'll see examples, in which case you can actually see a whole bunch of code that you can just run already, no problem here. Or you will see vignettes. I usually am a bit happier if I see vignettes, because vignettes are little stories about the data. They might have more complex analyses. But this is really cool because this is basically sort of a ready-made analysis. I feel a little guilty here. I don't have to do as much work as I thought, because look at this. R is going to do it for you. They even have a comment to the right. So this data function, if you type it by itself, I kind of did it. I didn't want to, but I listed all the available data sets. So this is for every package that we have. And I apologize if the connection is unstable, but keep in mind, this only is for the packages that we have installed. So what do I have? I have a datasets R package. I have the foreign package. There'll be some good data sets there. I want to see if I have Mosaic installed. I think I do, because I've been doing some analyses. Yeah, so I have the Mosaic data package installed. So you'll have most of these as well. If you don't install Mosaic and all of its dependencies, that is the packages that are also required, then you won't get those data sets. But I would say install, if you're going to install some packages, I would install the foreign packages. There's a couple of good data sets there. And then I would also install, of course, and we'll do the, it wants me to restart it. I don't really care. Then we'll do the library for this foreign package. This is a package that is actually relatively interesting, because it actually helps us import foreign data sets that are not within R. And here I am misspelling the package name. But there are also data sets that come along with this. It's like a family, basically. You're not only inviting the parents, you're inviting the kids here. So you can install these packages, but we're going to install our good old friend, this Mosaic package. Believe it or not, there's actually some pretty good data sets out there. I'm being a little redundant here, of course. I don't have to type these commands here. What is it saying? Updating the loading packages. We're going to restart it, sure. I don't like to restart my R session when I'm sort of demonstrating it, but that's okay. Because one thing I do want to illustrate is this historical data sets package, as well as some, oh shoot. Is this going to take a while? I hope not. In any case, I'm going to illustrate some cool stuff with the historical data sets package that is really, really neat, that's underutilized. And I think it'll be cool for, for you to use, right? Because these are all basically requires very little effort on your part in terms of data cleaning. So we can list all the available data sets. I think we have these installed as packages. If not, I'm going to just do it here. We're going to do this Mosaic, or do the Mosaic core. We'll do the Mosaic data sets. And I'll see if I have this other package that I want to talk about. And I'm going to install it here, actually. It's called hist data. Capital H, capital D-A-T-A, I believe. Could be wrong. There was a nice article about it. So there are magazines about R, and one of them, I forget the name of it now. It is case sensitive. No. Okay, well, hold on for a second. I actually just looked at this because it is in the list of data set sources that I have given you in the class. So forgive me for not showing you this. Hold on for a second. you know what I'm going to do? I'll show you. If you encounter something like this, you're going to use something called the help search function. This is basically going to search the R universe, it should, for the concept or package or whatever it is that you're looking for. And did that work? Often you have to maybe look for a particular command. No. Maybe you have to look for the name, historical data. And I'm just going to click at the end of that line because I can run it. Okay, so no results are found there. I do have it. Hold on for a second. You know what? Okay, I'm not going to give up. This is silly because, hold on. You're going to go to home. I don't do this enough. So this is actually good for me because I don't actually use the CRAN task views. There's something called CRAN task views here, which is a great resource. Basically, as I've mentioned this before, R is great because it has tons of packages. It's also probably a problem because it has so many packages. And I'm going to just show you one, what happened when I clicked on this link right here, CRAN task views. You actually see a plethora of different types of analyses depending on your focus of study. I almost didn't want to share it because maybe it could be a little distracting. I'm going to reshare the screen. You're going to see the CRAN task view screen. There it is. This is my web browser. You'll see here, CRAN task views is basically a curated subset of R packages organized by particular domains or areas of research. Why is it relevant? Because if you are interested in a particular topic of study, such as, say, pharmacological analyses, then guess what? These kinds of data packages, these families of packages or families of analyses are going to include data sets that are going to be more relevant. So if we click on econometrics and we install econometric packages, we're going to actually incorporate analyses that, or data sets that will include econometric models or econometric data sets. So for example, one notable package is this CAR package by John Fox. I thought he was a sociologist, but basically, if you look at this, I thought it includes the data set. Well, if you look at the reference manual, it'll usually include a description of the data sets here. Yeah, here it is. It says CAR data. So this CAR is actually a good one because you can look at the data sets here. And it's basically a companion to this website. So hopefully it'll open up. So if you want econometric data, so data sets on, oh, I don't know. Oh, see, that doesn't seem to want to open, which is annoying. But the point is, this is another example where you have lots of data sets. So in fact, I'm going to add it to our list of packages that we're going to install. So maybe we don't have the historical data, although I did have that. If I can just slow down and I'll find my PDF. Hold on for a second. I'm just going to go through my history, and I'll go to the PDF of files that I have uploaded. Final project data sources. Yeah, there it is. So let's go back to our RStudio screen. We're going to do a new share, and we're going to share RStudio. There we go. So here we are back at home base, and I'm going to share this hist data package. Is actually, yeah. I thought I typed it out correctly. Oh, you know what? It looks like the project location had changed, so the path file had changed. So that's one of the issues with R, is that things get updated, but also path files or links, external links to internet links get broken. That's all the more reason to have your own location for you to do your analysis. So hopefully I'm getting redirected here, but see if I can still try this. Hist data should be the one. It should be install packages. By the way, if it does that autocomplete thing, you can press tab and it should work. And it should be, this is what it was called. Let's see if we can run that. All right, we got that, good. And then we're gonna do library or require, this is the same thing, this hist data function, because it's really cool. And these are historical data sets. We're also going to install this car package, the one that we found through CRAN task views. Look at that. Those are good data sets. Those are good packages. And they're, as you saw, they're organized by topic. So if you're really interested in, as I said, pharmacology, go ahead and look at that. There are data sets like time series data sets that are more interesting for other areas of research. But it really depends on what mission you want to do, right? If you want to be an economist, the car package will work. This is sort of our, and it's something where you don't necessarily have to install these packages, by the way, for them to actually be used. That's kind of it's an optional argument, but I'm trying to keep things simple here. Because what we're doing here then is we're installing and downloading some packages that are really notable. This datasets package. We did install the foreign package. We did the foreign package. And I'm actually going to cut and paste these, and I'm going to put these packages that we install and load in the same place. That's just sort of, it's good kind of, I don't know, good data hygiene, as we say. So the goal here is to basically look interactively within, and I apologize if we have some problems here, and do some warning messages. Car is a little bit old. It's been around a while. The point is you can work within the CRAN task views, and you can basically find data already. We don't even have to leave R. So now, as we saw from the help file from the data function, right? Let's click on that, and we're going to get that again. We scroll all the way to the bottom. We're going to get all available data sets. Well, guess what? We're not going to get just the base R data sets. We're going to get them organized by group. I'm going to save this script because you can see it's red here. So we're going to get all available data sets. It's going to open up here, and it opens up as a different tab. But notice what it starts with. It starts with the name of the package, and then a list of the data sets within that package. So the car data set, this is the car package that we just installed, includes some interesting examples. So one of them is the American Math Survey data set. Another one, see if some of these are pretty recognizable. The British Election Panel Survey is a famous study. Panel simply means, well, it can mean different things. And if you're an economist, it'll mean it's longitudinal. So it occurs one after the other. Some of these are really famous data sets, and this is why I encourage you to maybe even look at the historical data sets, because it's a way of revisiting statistics or different fields of research. So, and really do what they've done, what the original researchers have done. Duncan, the one I have highlighted here, this is Duncan's occupational prestige data. Okay, well, what if we want to know more about that? Well, we can basically, if you look at this, it'll say help. You can get help on that. If you do help, sorry, if we go to our script, and we're interested in this Duncan data set for several reasons, but mostly because it's an interesting data set because it's within sociology, my home discipline. It's really one of the first ones that showed that a father's education or parent's education is associated with their child's outcome. We never really actually had longitudinal data until the 1950s. It was too expensive. It was difficult to collect. And this created a whole school of what was called the Wisconsin School of Mobility, meaning, okay, if your parents are poor, are you going to be mobile and go raise up the social hierarchy or not? But look what I did. If you type help and then you type in the name of the data frame, the built-in data frame after you've installed the package and loaded the package, you don't have to specify anything else. Now this is a risk as well, right? Because you might have so many data sets and data frames installed that you might want help with for, I don't know, a particular function, a particular analysis, and actually you're going to get something which is actually describing a data set. And this is is about the same as a help file, except in the sense that it has a description, it has usage. It's kind of silly, right? You have the fixed with script here, which is the name of the data set, and you have to be specific about the data set, so it's a capital D. And then it has the format. This is pretty nice. This is essentially what is known as in stats as a code book. Often this will be located as a separate PDF or a separate text file apart from your data set. So this is pretty normal for you to have something that will describe the columns separately from the data set. So here we have the columns, here we have the data set. Well, we haven't actually even loaded our data set into this environment, but we know quite a bit about it already. We know the type. So there's an occupational type. We know income. That's probably going to be a numeric variable. We have education. Percentage of occupational incumbents in 1950 who were high school graduates, which were we cynical, we would say is roughly equivalent to a PhD in 2017. This is someone making a joke, by the way. This is one of the funniest things I've read, right? A high school graduate is equivalent to a PhD in 2017, cynically. I don't know if that was John Fox, because he's a well-established economist, but he would have a sense of humor, I'm sure. And then we have this idea of an occupational prestige score. What's relevant, especially when you're writing about these data sets that have been analyzed and used before, reference what has been done before. Reference John Fox, who made these data available. But also, I would encourage you to go to Google Scholar, scholar.google.com, and type in this and look at this and look at the original data set and revisit history. Because this is a really cool thing. This was a very famous, a landmark study, the Blau and Duncan study of occupational attainment. Well, here we have basically the data set at our fingertips. Now, how are we going to get it into our, working environments? Well, I want to do a couple things here. I want to know a little bit about what this is, and I just want to show you that when we do this, there's a nice kind of general function called the structure function. Whenever you have an object that you are loath or worried about putting into your environment, and you're not sure what it is, use this. This str is short for structure. You can actually do a help for it. You can do a structure on a structure. It's kind of auto-recursive, right? Structure. But this is a nice command because it basically, every object, no matter how stupid it is, has a structure to it. You know, I could define X is, and I'm going to assign it to this is a useless object. And then I can do a structure on this. So if I define an object, a pretty stupid object, here it is, it's useful for us. And it tells us this is a character. So and of course our environment tells us that as well. Now when we have an object, sometimes if we do put it in, we also want to remove it. This is what the rm function will do. So let's remove that useless object. We'll probably encounter plenty of those, especially when we're exploring data sets. Notice I'm using extensively this assignment operator. There's a keyboard shortcut for it. I'm forgetting it at the moment, but we use this instead of the equal sign in R. Essentially to the right of this is what is being defined, and then the X is the whatever symbol we want to use to characterize it. And look how cute RStudio is. If I highlight the first instance of that object, it'll highlight every other one in the code. It's kind of subtle here, but you can do it. But I'm going to do Shift-Command-C on my Mac and comment this out because I don't need to remove it. I don't need to put it into my environment. What we want to do now is, once we have found our data set, we now want to actually input it or basically input it into our working environment. All right, so we've identified it, we've looked at it. But before we do that, I'm going to actually spend a little bit more time and just show you, scroll down, look at all these other files, all these other data sets. This is a base package. You're going to see this one that I'm totally sick of called the iris datasets. If it's not here, I'm going to be happy. Yeah, Edgar Anderson's iris dataset. Almost every package in the world will have Edgar Anderson's iris dataset. 5 variables, 4 of them having being numeric, the 5th one being categorical or a factor variable. There's still some cool data sets there. They're a little, I don't know, not as fun, but pretty cool stuff here. There's a data set on Star Wars characters. Of course there is. ggplot, these are all dependencies. So these are data sets that are installed along with R. While this is not a social science project, the student did come to me, was interested in Old Faithful. This is a geyser in Yellowstone Park, and the student had basically looked at the analysis of whether or not the timing of Old Faithful was related to the intensity. It was a really cool analysis. It was something that probably was done before, but something that was still very interesting. I still would encourage you to try to go for more social variables or data sets. So look at the Midwest graphics, demographics data set. That sounds like something to be somewhat more interesting. So you can even do that. You don't have to type it in the script. And you can see what it is. You see the name. PID is a geographic area. Looks like these are all geographic areas. And there are descriptions here. So that's actually looks pretty interesting. It's like our country data. It's like our political it's like our mission on correlations, except we're looking at demographics. Some cool stuff there. What I want to go to is Mosaic data. We actually have quite a few cool data sets here that we included in Mosaic. Not as many as you might imagine. Where's the historical data set though? Oh, did I just cross it over? Hold on for a second. I want to show you the historic. No, we don't have it installed. Okay, hold on for a second. Why is that? Hold on. Yeah. I accidentally clicked on this. Okay, hold on. I don't think if I look at the historical data, did we not? I want to put that in our library. That's warning that it's an older version. There might be some issues with some of the cross dependencies. We'll see. But if you look at the packages, I just want to make sure that it was loaded correctly. Okay. Interesting. This might be something that I have not noticed before. It's possible that because it itself is a data function, the hist datasets function, the list of datasets from history of stats and data visualization, it might not be in the list of all datasets in our base data function. This is when R gets a little confusing. I thought it was here. There we are. So here we have the list of data sets in the hist package. As I said before, they're listed according to kind of group or package. Now, if you recall, we type in data and a question mark, and we go to that help file again. I use the console a lot, of course. And I apologize if the internet's connection is a little bit slow. I feel like it is. I want to show that this package argument permits us to give the package to look for in data sets. Right now it's set to null, basically. By default, all packages in the search path are used. And so it's looking everywhere on our hard drive, on my machine for the package, but we don't want to list all available data sets. Let's just list those that are in the historical data set. So list the data, and then we're going to do package, and then equals, and I believe this is in quotes, hist data. It doesn't autocomplete. That's a little troublesome. Let's see if that works though. And there you go. So you have the number, and you have basically all the data sets here. And some of these are really cool, really famous. Notice we have students t-test yeast counts. So if you want to, no student has done this, I encourage you to do this, please. Take a look at students yeast. Look at that. I think that's really cool. There's a neat data set on this stats on deadly corals. Some of these are quite old data sets. So the earliest data sets were really concerned with morality, especially the French. So the French had the Parent du Chalet time series on the number of prostitutes in Paris, because they considered statistics to be a moral, kind of a moral crusade in a way. If you want to know the most famous visualization in history, you would probably see it, that it is the failure of Menard's famous, what's not Menard, Napoleon's famous loss when he invaded Moscow during the winter. And there's a famous graphic out there, you might have seen it. Florence Nightingale is included in this. When we talk about Pearson statistics, Pearson R correlation, here's a data set by Pearson right there. Thought it had Galton. It does still have Galton. So when we talked about regression, look at this. We can do regression analysis on Galton stuff. Anyway, I don't want to go too much into that, but there's just a lot of cool stuff there. There's stuff on the Armada. This is the Spanish Armada. The point is, oh, and this is a really cool data set. Last one. This is one of the earliest data sets that showed statistical significance between two means, because there was actually enough data to show that there are slightly more males than females in London at the time. So when we go back into history, when we go into the past, there's less data. Right now we're swimming in data. But I still encourage you to look to the past, look to history, because it's not only good for pedagogy, but because you might disprove something, right? You might show that Galton made some mistakes, but it also allows you to understand, I think, the history of and the concepts that are taught. So, and I had spoken about the morality of statistics, its moral sort of cultural basis. Here of Gary, he wrote an essay on the moral statistics of France. When they talk about moral statistics, they're often talking about what is the ideal citizen. This is something that's very, very French. Anyway, I didn't just hopefully take you down memory lane there, but I also showed through CAN task views the wide variety of data sets. And here we have we're going to go back to our Duncan dataset, and we're going to basically do a couple things. We're first going to put it into our global environment. We don't want it sitting out here. It just kind of, there's nothing you can do with this data set. So we're going to define it. And I like to use DF. It's sort of conventional, but you can call it whatever you want. Oh, yeah. I apologize for the internet connection again. R doesn't like it when you basically define an object, if you notice, incompletely. See that little X there? It really just doesn't like unexpected end of document. It really just doesn't like it. So even when you type a 1 parentheses, it'll close it for you. But it still doesn't like this. This is unexpected token. Yeah, there's just nothing there. So what are we going to do? We're going to use some base functions here. We're going to actually, well, since this is a here, I think these should be yeah, we'll do this. We're going to do what we've done in class, which is this load is the generic formality file.r data function. I could be incorrect. If I don't use enough of the built-in data sets. These might not be our data files, but I think they are. If they're not, all the better. But let's just try that. I actually don't do this as much, but let's do it. So what we're going to do is we're going to load Duncan into our, yeah, I didn't think so. Do you know why? Because we can do this. Let's take a look at our Duncan data set. Remember, it's just a name. So the fact is it's there. Okay, so it looks like it's a data frame. And if we did that, already did the structure, and I just want to look at this again because I want to take a look at the, yeah, okay, it's a data frame, but I'm going to use a more flexible argument. This is how I would do it. This is how you read and write any delimited text file. So basically, you can also use something called the readR function. So, but the canonical one is read table. This means that anything that's delimited, you have a cell, space, and use something delimited. So this is like space delimited. A very common type of file is a .csv file. But you should be able to read this in. You know what, I just realized, I think I'm holding myself off from doing this because I don't want to take you down the wrong route. I'm going to take us to sorry, the data function, because the data function is a little bit tricky. because, yeah, okay, because the data function itself, that's right, it basically, the data function itself loads the data set into your global environment. So I'm sorry, this is not that common. It's a little weird, but we're going to do it. So here we have that data set. We're going to load it, and there it is in our working environment. You'll see for a while with some data sets, it'll have this weird promise thing, this unevaluated promise. Whenever you take code and you run it, we say you evaluate it. So it's still thinking here. Now, there's something I actually don't like about this method here, which is that you're not, when you're just loading a data set, loading, say, an R data set, or you're just loading a package, loading this into your global environment, you're not saving it as, you're basically letting it sort of sit around in your environment without any kind of, how do I put it? Without any kind of basis, or without any kind of structure in terms of what it is that you want to start off as your raw data set. Because sometimes you might want to start your raw data set as simply a subset of existing data. Maybe you're only interested in, say, female passengers of the Titanic data set. That's a great analysis. That would be a great project. But you want to start off with those data before you do the analysis. You want to have data, analysis, and then results. So it's taking a little while here for this data function to work. You can also do this. You can assign it a DataFrame function. So if you have many data frames, df is often used as sort of a prefix for DataFrame, and you'll often use periods here. So we could call this DataFrame Duncan, and you're basically taking this data that you load, and you're going to call it by the different name. I like this more because you basically have, it's reading it in as a value. All right, well, that's probably because of the, whatever. I'm going to remove that. Okay. So you have the data frame here basically read in, but you also have a lot of other kinds of data sets that you have available that aren't just within the R environment. But before we do that, I kind of want to show you how to save this thing. You can press this little floppy here. If you're old enough to remember what a floppy is, don't copy that floppy. That's what that little thing is. You can save a data frame that you have. Right now it's reading in as values. A data frame will be labeled a values object until it's totally read in. I think I'm just having a bad internet connection, and I apologize for that. It's not a good deal for you guys. Let's try it again. Yeah, I'm gonna erase that. Sometimes this doesn't always work, but sometimes if R is running a little bit slow, I know I have a lot of data sets open, it'll sometimes go a little faster. Okay, I don't spend too much time on this except to say that when you use the data function, you basically, yeah, you can load the data. And that's similar to the load data function that we used before. So if we use an R data file, you would say load and then use file.rdata. Most data sets aren't going to be in R dataset formats, unless you save it that way. And you can do that. So then if we have this data set here, I'm being I'm a little irked because I want this data frame to load, but it's not going to load. Let's try our friend the iris data set. Someone's mentioned it. Hello? I apologize. I think I'm having some internet difficulty here. Sorry. There's for some reason I have a connection issue. Well, I'm going to end. We only have like 5 minutes left, and I really hate to do this. So what I'm going to do, if you can hear me, is I'm going to stop the share. My internet connection is not working right now. What I want to do is I want to actually, what I'll do is I'll load this up if I could have recorded it, but I also wanted to take you through two other commands. One is called the read.table function. The other is read.csv. A CSV file is something you're going to see everywhere. It simply means comma separated value. It's anything where you have a comma separated file. However, you can read almost anything with the read table function. You're going to read text files. Text files and CSV files are the most common types. If not, you can import using the drop-down menu. So what we'll do then is, given the internet problems, I will do a different section. I'm sorry, I will record videos of those and upload those to the course website. Unfortunately, it seems like it's not something that I can do real time. I think it's because I have too many data sets open. And you're probably hearing this over the hiss of the fan. But I'm just gonna show you guys, because you've been here, you've been patient. When you do have a data set open, let's try that part. So I'm going to tell you one thing. I'm going to stop recording. One thing about R that Pythonistas say in these kind of wars between, you know, which package is better, or which programming language is better. People who use Python will say R is pretty slow, and that's because R, whatever you're reading into memory with R, you basically have to read in everything. So if you're reading in 4 data sets, you're going to read in all 4. It could be that I have because I wanted to show you multiple data frames, I might have, you know, slowed this down, because I want us to see what the data frame looks like when you type in data, comma, you know, parenthesis, iris or whatever. It's not a big data set. So I apologize, but yeah, it could also be this darn internet connection. But I want you to look at these functions here. I'm going to share the screen. So I want to end on something good and useful, because I apologize if it's just a waste of your time. But I will record these, the lesson plan, and we'll have basically the 3 on, one on built-in data sets, one on the read table data sets, and then one on read.csv files. CSV files, look for them, they're ubiquitous. Look at the discussion board, comment on it. Someone noted there was a typo. I didn't notice this, but I just want to show you with RStudio. I encourage you to do a couple things here. Just look at this function here. This is important to look at. So at least we can do this. Now I know something is missed because the iris data set is not running. Does not work either. It's too slow. Really. Okay, so read table. That table, basically, it's one of the most useful flexible functions you can have. And then the opposite of that is a write table function. Similarly, when you load a data frame, you can also write it. And you can write it as, I would typically write it as a CSV file, but you can also save it as our data frame. And I'll show you how to do that. I'll have to record these for videos. I see some comments, but I'm not sure if I get those messages. I'm sorry. Hello? Oh, man. I'm sorry. Oh. All right.